Hi. Today we will be discussing the alternating series. The alternating series is a series of numbers with alternating positive and negative terms, with a bn which is greater than 0. The bn is a positive number, which is actually the absolute value of an. When testing the alternate series to test for its convergence, we use the term -1 to the n minus 1 bn, and there's two terms that has to be fulfilled. The first is bn plus 1 has to be less than or equal to bn for all terms of n. Secondly, the limit as n goes to infinity of bn has to equal 0. If both terms are fulfilled, then the alternating series is indeed convergent. Now here we have a chart that shows that partial sum 1 is greater than partial sum 2. You can see it right here, partial sum 1 is greater than partial sum 2, which is greater than partial sum 3, all the way down to s. Continue on. We can see that we can prove this. S2 equals B1 minus B2, which is greater than or equal to 0, since B2 is less than or equal to B1. S4 is equal to S2 plus B3 minus B4, which is greater than or equal to S2, since B4 is less than or equal to B3. In general, we can say that S2n equals S2n minus 2 plus B2n minus 1 minus B2n, which is greater than or equal to 2n minus 2, since B2n is less than or equal to B2n minus 1. So, 0 is less than or equal to S2, which is less than or equal to S4, which is less than or equal to S6, and so on and so forth. Now, to prove it further, the limit as n goes to infinity of S2n is s. We also find the limit as n goes to infinity of S2n plus 1, which would break into the limit of S2n plus B2n plus 1, which we separate into two different limits, which turn into s plus 0, which eventually equals s. Since both partial sums, positive and negative, equal s, then we can determine that the limit as n goes to infinity of Sn is indeed s, and therefore it is convergent. Now we have a couple of examples here. We have the sum of -1 to the n minus 1 over n. We can say that 1 over n plus 1 is less than or equal to 1 over n, so the first term is correct. And the second term, limit as n goes to infinity of 1n, does indeed equal 0. So both terms of the alternating series test are correct. Therefore, this series is indeed convergent. The second is -1 to the n times 8n over 9n minus 1. Now, it's an alternating series, but the limit turns into 8 over 9. So we have to test it a little bit further. We have to say whether or not it's convergent or divergent using the test of divergence. And the limit of this term does not exist, so therefore it diverges. Finally, we have the sum of -1 to the n minus 1 over 2 of 2 divided by 2n plus 1. Now, we take this and we rewrite the term. The first test does indeed show 2 over 2n plus 1 is greater than or equal to 2 over 2n plus 2. So the first term is indeed fulfilled. And then secondly, we check to see if the limit of 2n plus 1 is equal to 0, and it is. So therefore, this original term is indeed convergent.